Hello there, Mr. Chan here for Algebra 1, 7-2, multiplying polynomials. Please go ahead and grab your student companion, note taker, and turn to page 141. And let's get started here. I'm not going to do the opener. I would like to put some review information here underneath this page right here. So let's go ahead and scratch A, B, and habits of mind. Before we can multiply polynomials, we have to remember what it means to add and subtract like terms. So from 7-1, adding and subtracting like terms involves having the same number of variables. Write this down. What does change are the coefficients. These are the numbers in front of the variables. We know from elementary school that 3 plus 5 is 8. We know that, of course. In terms of like terms, what if we have 3x plus 5x? Well, the number of variables are the x's. The coefficients are the 3 and the 5 in front of those variables. 3 plus 5 is 8x, etc., etc. So that's what it means to add and subtract like terms. Only the coefficients change. In terms of multiplication of exponents, here's a quick overview of the properties of exponents. They are a to the m times a to the n. The rule is to add the exponents. As you recall, that is the rule when you're multiplying exponents. So this is a product of powers. This is what it's called. This only works if the base is the same. Keep that in mind. Quick example would be like this. X to the third times x to the fourth. This becomes x to the seventh, okay? Likewise, division might play a role in this particular section. When we're dividing or quotient of powers, the rule is to do opposite of add, which is subtract the exponents. Okay? That is the rule. Yay. All right. Let's move on to the next page and try some problems involving multiplying polynomials. Polynomials can be monomials, binomials, trinomials. That's the number of terms in each polynomial. Let's take a look at numbers 1a and 1b. Now, before I actually do actual variables, I want to do something very simple and straightforward. What if I drew a rectangle? In this rectangle, there are two compartments. One compartment's bigger than the other one, right? The lengths of the compartments are, let's say 3, 2, and 5. Let's just say that. Okay? If I ask you to find the area of this rectangle with two compartments, you can do it individually. Like for the left side, 2 times 3 is 6. That's easy to do. And 3 times 5 is 15. 6 plus 15 is 21. Isn't that interesting? That is the area of the big rectangle. Could I do this individually? The answer is yes. What I'm trying to illustrate here is the distributive property. So this is another way of looking at it. Could I get 21 another way? Well, certainly 2 plus 5 is 7. And 3 times 7 is 21, so you can get it that way as well. So a couple of ways of looking at things. 2 times 7 is, I'm sorry, did I say 2? I meant to say 3. So 3 times 7 is 21. Same answer. Down there, okay? So I'll just utilizing the distributive property. Okay, so you can represent multiplication using rectangles. Right now we have a monomial, negative 2x squared, times a trinomial, x squared plus 3x plus 4. We can draw a rectangle if you want to represent that. Some kids like that. There's my monomial on one side of the rectangle, and then my trinomial up here. And you can literally multiply. You can do it with the distributive property, and that's what we're going to do here. We're applying the distributive property. And from way back when, the distributive property basically says if you have something times a polynomial, you're distributing it by multiplying that. So a times parentheses b plus c is simply ab plus ac. That is the distributive property. I'm going to do the same thing here. Let's multiply. Here we go. Negative 2 times x squared times x squared is negative 2x. Now, what do we do with the exponents? 2 plus 2 is 4, okay? That's something you have to do mentally in your head now. The variables get added up here. That's the first product. Second product, let's do that next. Woo! Negative 2x squared times 3x is negative 6x. Add the exponents. 2 plus, there's an invisible 1 right there, is 3. Let me know if you have any questions. And then finally, the back end here, whoa, distributive property, negative 2x squared times 4 is negative 8x squared, okay? Not only do the coefficients get changed because you're multiplying the coefficients, but the powers change as well. That is something that I just created. That's called the distributive property. And that, ladies and gentlemen, is your answer. None of those can be added together. That's your final answer right there. Second problem. Let's do a box again to represent the distributive property. We have negative 4x on one side, and of course, 2x squared minus 3x plus 5 on the other side. Let's go ahead and distribute. Here we go. Negative 4x times 2x squared. Now, negative 4 times 2 is negative 8. Okay. The negative 4, then the x part is x to the first times x squared is x to the third, because 1 plus 2 is 3. Second distributive, second product. Watch out for this one. Negative times a negative is a positive 12x. Let's count the x's here. X to the first and x to the first is x squared right there. Then finally, the last product is negative 4 times 5 is negative 20x. And there's your answer. Not bad. We're going to do some more products. Any questions about numbers 1A, 1B? All right. Number 2, they actually have rectangles for us. We are going to be multiplying sides that are more than just monomials or binomials or trinomials. Take a look at number 2A, 2B. Looks like we are multiplying a binomial times a binomial. There's 2x plus 4 and 5x plus 2, so that's 2 times 2. And in the middle, that'll create 4 little areas. Okay, here we go. Let's do the upper left-hand corner. 2x times 5x is 10x squared. We're multiplying now. The variables change as well. Great. Second box, 4 times 5x is 20x. Nice. That's also positive. Third box, lower left, is 2x times 2 is 4x. Nice. And then finally, 4 times 2 is 8. I have 4 terms right now. But with that, I got to check to see if any of them can be combined together. Here, you want to combine like terms. Okay. Notice the 10x squared stays the same. That doesn't go anywhere else. I don't see any other x squares. However, I have a 20x and a 4x. Those are like terms. 20 of those plus 4 of those is 24x. We're not multiplying now, we're adding. When we're adding, don't confuse that with multiplication. The coefficient changes, not the variable, right? 20 bags of M&Ms plus 4 bags of M&Ms is 24 bags of M&Ms. We're not changing in M&Ms. And then finally the plus 8. And ladies and gentlemen, there's your answer for number 2A. This is a two-step process. Multiplication changes not only the coefficient and the powers, but then the second step, when we're combining like terms at the end, you don't change the variables, you only change the coefficient. It gets a little confusing sometimes for some students, so be careful out there. All right, same idea with the second problem. We have a binomial times another binomial. Let's go ahead and do this. 7x times 2x is 14x squared, because x times x is x squared. Second product, 2 times 2x is 4x. Nice. Third product is 7x times 1 is 7x. And then last product, 2 times 1 is 2. Again, look to see if you can combine like terms. In this case, I can. 4x plus 7x is 11x in a moment. So keep that in mind. Those are like terms right there. 14x squared, though, stays the same. 4 plus 7 is 11x, the middle one. And then the 2 on the end. All right? All right. Not too bad. Multiplication is not too bad, as long as you know your properties of exponents. All right. Well, we're going to just keep going. All we're doing is multiplying. Whether they present the product with rectangles or with actual algebra, it's all the same. It doesn't really matter, okay? I mean, you can use a box if you want to. If you don't want to, that's fine too. All right. We're going to do multiplying binomials. Now in algebra, they might say FOIL, which sounds kind of weird. Is this different from distributive property? The answer is no, not really. F stands for first terms. O stands for outer terms. When it comes to a binomial times a binomial. I stands for inner terms. And L stands for last terms. It's actually not a big deal, okay? I'm going to do number 3A both ways. We have 5x minus 4 as my first binomial times 2x plus 1 for my second binomial. Let me zoom in a little bit so you can see a little better. All right, let's go ahead and do this thing called FOIL, which is basically the distributive property with 2 rows, basically. All right, here we go. Woo! Those are my first terms. Those are the first terms of both binomials. 5x times 2x. Yay. O are the outer terms. Whoa! Plus 5x times 1. I stands for the inside terms. Those are the inner terms. Those are relative to each other. That's going to be minus 4 times 2x. Watch out for those negative signs. L stands for last terms. Whoosh. That's going to be minus 4 times 1. Then you clean it up. It's just like the last few problems we just did a moment ago, but in a nice orderly fashion here. Here we go. 5x times 2x is 10x squared plus 5x times 1 is just 5x. And then minus 8x, because 4 times 2 is negative 8, and the x, and minus 4. Out of those 4 terms, 2 of them can be combined a little further, the middle 2 usually. Not all the times, but usually. Watch out for those, okay? So the first and the last term stays the same. 5 minus 8 is negative 3x. Yay. And there's your answer for number 3A. Could I do this with the box? Of course you can. No one's stopping you guys. No one's stopping you at all. See what I'm doing? I'm drawing a 2x2 rectangular box, and you can just do all that stuff here as well. No big deal. Okay. And oh, and of course, we have these that can be added together right there. Okay. Yay. Any questions? Why don't you guys try with me 3B, same process. We can just throw it in a box right away. No big deal. A lot of kids like boxes. Ooh, I think there's a typo there. See that 2 plus 4 right there? Let's make that 2x. Yeah, that's a typo. They left that out. Whoops. Happens. We just fixed it. All right, first terms, 3x times 2x is 6x squared. Outer terms, 3x times 4 is 12x. Inner terms, negative 5 times 2x is negative 10x. And last terms, of course, negative 5 times 4 is negative 20. So I'm just going to color code this just to show you. I'm not going to actually rewrite that again, but that's what we just did in the box. The inner and the outer terms happen to have the same variable x, and those can be combined together. But we have our final answer here, 6x squared. We have negative 10 plus 12 is plus 2x, and then minus 20. Yay. Not bad. Let's go to the next page. Example 4, here we go. It's just more multiplication. We're just going to get bigger and bigger boxes. We're doing a trinomial, 3 terms, times a binomial, 2 terms. No big deal. Let's draw the box, okay? Let's get crazy here. A 2 by 3. 2 rows by 3 columns. 2x minus 5, negative 3x. We're doing 4a, by the way, of course. I kind of call this a superfoil, right? All right, here we go. Watch my coloring here. So I'm going to do this. 2x times that trinomial there. Let's do it. Negative 6x cubed. There's a little 1 there. Be careful there. Then 2x times 4x is plus 8x squared. 1 plus 1 is 2. And then 2x times negative 7 is negative 14x. That takes care of the first row. Second row, here we go. Negative 5 times negative 3x squared is positive 15x squared. Negative times the negative was a positive there. Next product, negative 5 times 4 is negative 20x. And then the last product is negative 5 times negative 7 is positive 35. So far, 2 by 3 gives you 6 terms. Take a look at your terms that are inside the box. Can any of them be combined together? Oh, look, x squares can be combined together. Oh, look, x's can be combined together. So those 2 pairs can be combined together, giving you a final answer. And I like to put it in descending order, the highest power first. Teachers love that. The second term are the x squares. I have 15 plus 8 is 23. Nice. The third term, negative 20 minus 14 is negative 34x. And the last term, of course, is 35. All right. Kind of a lot of work there, but it works. Let me know if you have any questions. Letter B, another 2 by 3? Okay, fine. No big deal. Let's do it. 2 by 3. It's just work, you know. You just have to keep track of your powers, keep track of your variables, combining like terms. All right. Let's multiply here. Here we go. Let's do the first row here like this. That's my first row in red. Negative 3 times 2 is negative 6. Let's count the x's there. X squared is x to the 4th. Second product, negative 3 times 3 is negative 9. X, let's count that. X squared and x to the first is x to the 3rd. Nice. And last, next product, negative 3 times negative 4 is negative 12x squared. Nice. Second row, Let's do it. 1 times everything. Oh, that's everything. Now this is kind of interesting. Looking at these 6 terms here, there's only one pair that can be combined together. And an extreme diagonal right there. Those are the only 2 that add up together. Everything else is the same. Dun, dun, dun. 2 minus 12 is -10. How are we doing? Doing okay? Yeah. I know. Circle that answer. Yay. All right, we're actually going to skip number 5. And we're going to talk about number 6 briefly, but not do the whole thing necessarily. Suppose the height of the phone in example 6. Oh, this is the actual bookwork. Were 1.9 times the width, but all of the other conditions were the same. What expression would represent the area of the phone's surface not occupied by the screen? All right, we're talking about cell phones here, ladies and gentlemen. Draw a cell phone that looks like this, please. This cell phone has a bezel like that. Bam. Now here are the dimensions that are from the textbook. At the bottom, the chin, there's a 2 centimeter gap there. And around everywhere else, there's a 1 centimeter gap right there, 1 centimeter gap right there for the bezel, and 1 centimeter gap right there. Okay? And they tell you that the width of this is 1.9 times the length, I'm sorry, is 1.9 times the width. So let's assign it a variable. The width is x, top to bottom there, and the length is 1.9x like that. Question: what expression would represent the area of the phone's surface not occupied by the screen? So we just want the outside area, basically the area of the frame. That's the strategy. Area of the frame, not the screen. The screen's on the inside right here, right? Y'all see that? So basically, this is like a donut. We got to find the area of the frame. The frame, I'll go ahead and color in green right here for you guys. We're just trying to find the area. Right now, easily, you can just tell this is a couple of rectangles, right? And when it comes to donuts and donut holes, same thing with this cell phone, take out the screen area, right? Take out the screen, meaning subtract. That's our strategy. Our strategy is to area of the big rectangle minus the area of the little rectangle, the screen. And that's our strategy. We're actually going to set it up and actually do it. All right, area of the big rectangle is, length times width, right? Area of rectangles are length times width. So in this case, it's the length is 1.9x times x. That's the big guy on the outside, minus the little guy. Now the little guy is a little trickier. We have to subtract away some of those particular centimeters, right? So length, in this case, for the screen is 1.9x minus these individual lengths right there, 2 and 1. You guys get that? So this is going to be 1.9x minus 3, because 3 is 2 plus 1 centimeters. Okay, that's your first part right there. Times, let's go the other way, x minus, and we got in this case 1 and 1, that's 2. And ladies and gentlemen, that is the strategy on solving this. I'm actually kind of satisfied that we set it up. Big rectangle minus little rectangle. Let's jump to the last page. Woohoo, not too bad. All right, let's jump to number 5. Oh, look, it's a monomial times a trinomial. Let's draw a rectangle, right? So the distributive property. Let's clean it up. Negative 2x cubed for the monomial, 3x squared minus 4x plus 7 for the trinomial. Let's do the first product here. Negative 2 times 3 is negative 6. Ooh, let's count the x's there. 3 plus 2 is 5. Next product, negative times a negative is a positive 8. X to the, not third, the fourth. There's an invisible 1 there. 3 plus 1 is 4. So be careful there as well. Finally, the last product, negative 2 times 7 is negative 14x to the third. And lo and behold, ladies and gentlemen, that is your answer right there. Yay. You guys like boxes, or you can draw those rainbows if you want to. It's up to you guys. How about number 6? Let's do that one. Oh, it looks like a 2 by 2. Yay. We have 2x plus 6 and x minus 4. Let's go and FOIL this. 2x times x is 2x squared. Outer terms, 2x times negative 4 is negative 8x. Inner terms, 6 times x is 6x. And last terms, let me know if I'm going too fast. 6 times negative 4 is negative 24. Two of those terms can be combined together. 6 minus 8 is negative 2. So let's rewrite everything in descending order. 2x to the square. 6 minus 8 is negative 2x. And then minus 24. Yay. Multiplication is not that bad, is it? I'm just doing a bunch of multiplication here. All right. Number 7. More of the same stuff. Let's do it. I'll let you guys try to do it by yourself at your desk quietly. When you're ready, just look up. Sometimes I do way too much work and I don't expect anything from you guys. You guys try this on your own, okay? When you're done, just look up. Well, how did you guys do? Let me know if I made any mistakes, but that's what I got right there using a box. Could I have done it without a box? Sure. Could have done that, I guess. All right. Box seems to work for a lot of people. I'm just going to keep going. The next one's a super foil, 2 by 3. I'm just populating the length and the width of the rectangle, and I'm just going to go ahead and multiply. Here we go. First row, product, 20y to the third. Watch out for those powers. That's 5y to the first. 5y to the first times 3y to the first is 15y squared. And last term is 5y times negative 1 is negative 5y. Great. Second row. Multiply those two together and hope for the best. Ooh, watch out for the last one. Negative times a negative is a positive 2. Okay, looks like we can combine some of those. Nice. There's one pair that can be combined together. Negative 8 plus 15. And we have another pair as well. Right there. Okay. Let's give my final answer. 20y to the third stays the same. Negative 8 plus 15 is plus 7y squared. Negative 6 minus 5 is negative 11y and plus 2. Yay. Ooh. Wow. A lot of multiplication. Number 9. It's a 3 by 2. Okay, I'll just do it this way. Interesting. 3x squared, 2x minus 5, 2x minus 3. Let's do it. All right. 3 times 2 is 6. X to the third right there. 3x squared times negative 3 is negative 9x squared. Nice for the first row. Yay. Second row, let's do that one. 2x times 2x is 4x squared. 2x times negative 3 is negative 6x. Great. And last pair, negative 5 times 2x is negative 10x. Negative 5 times negative 3 is positive 15. We can combine some of these together. Yay. That diagonal will go together, and that diagonal will go together. And this will give me as an answer 6x cubed. Ooh, watch out. 4 minus 9 is negative 5. X squared. Negative 10 minus 6 is negative 16x plus 15. And there's your final answer in descending order. Very nice. Woo! Number 10. We've been doing boxes. I'm just going to foil this one. You guys mind if I just foil it? No big deal. Foil is just a fancy way of saying distributive property. Here we go. First terms, 4x times 2x. Outer terms, 4x times 4. Inner terms, negative 2 times 2x. And last terms, negative 2 times 4. Let's clean that up. 4, whoops, sorry, boo-boo there. 4 times 2 is 8, x squared plus 16x minus 4x right there, minus 8. The middle two terms can be combined together. 16 minus 4 is, of course, 12. And there's your area, ladies and gentlemen, area of that rectangle. Well, thank you for being patient and hanging in there. This last page was not too bad. If you have any questions about properties of exponents, let me know. But thank you very much. Have a good day. Bye-bye.